So what exactly is a hypothesis? Let's talk about that. In science, words have specific definitions. This helps us clearly communicate with each other, and that's also why we spend some time at the beginning of science classes making sure to carefully define our terms. So let's start with what is a hypothesis. A hypothesis is a provisional explanation of a phenomenon. You can think of it as an educated guess. I have researched this topic. I have a little bit of an idea of what is going on. So I'm going to make a prediction about what I think is going to happen. This is a way to explain observed data. So in this example, there's two hypotheses. Either the spider grew or our people shrunk. There are a couple of qualifications that we want hypotheses to have. We want them to be logical. They should definitely make sense. We also want them to be falsifiable. We want them to be consistent with what is already known, especially now. There's a lot of science that has already been researched, and it would make the most sense for a new part of any field to fit with what is already in that field. And lastly, we also want them to be simple. But let's start with falsifiable. What does that mean? Falsifiable simply means that it is able to be disproven, that there is some way that we can show that a given hypothesis is false. Because if there is no way to prove that it's false, well, then there's no way to actually determine if your hypothesis was truly supported or not. So in this example, do a bunch of math, a miracle occurs, and there's your result. That's not quite what we're looking for in a hypothesis. But let's start with an example. In our first statement, no alien spaceships have ever crashed in New Mexico. And here's a second statement. An alien spaceship crashed in New Mexico. Which of these two statements is falsifiable? If you guess the first one, that is correct. But let's talk about why. In this first one, if we find any part of an alien spaceship, that statement is falsified. So there is a possible way for that to be proven false. Still, we're probably not going to find that, but there are conditions with which we can disprove that statement. And our second one here, if it's wrong, all we're going to find is absence of evidence. So we're not going to be able to determine between a truly false statement and simply absence of evidence. So whenever you're formulating a hypothesis, try and think of these different opportunities and make sure that you are stating your hypothesis in a way that it can be disproven, even if that is unlikely. We also want the predictions a hypothesis makes to make sense. Hypotheses should have useful and applicable predictions. One of the critiques of string theory is, who cares? What does it mean? I am not particularly well versed in physics, but string theory doesn't have as many useful applications as other things as, say, relativity. We also want hypotheses to have simple explanations. There are two major rules you'll have talked about in this paradigm here. The first is Occam's razor. One should not increase beyond what is necessary the number of entities required to explain anything. And this really just means don't make it too complicated. Closely related is the idea of parsimony, that you want to choose the explanation that requires the fewest leaps of logic. We use parsimony specifically when we're talking about phylogenetics. When we want to test hypotheses, scientists are not particularly motivated to disprove their own hypotheses, but they are highly, highly motivated to disprove the hypotheses of other scientists. And this is how we have our checks and balances in systems. We have different labs researching similar phenomena, and they're all trying to prove that they have the correct idea and not the other labs. And once a hypothesis or a group of related hypotheses has been tested over and over and over again, that's where we get something called a theory. A theory is a collection of related hypotheses, and this means they have been vigorously tested, they are consistent with each other. And there's a lot of examples, gravity, electromagnetic theory, atomic theory, the theory of relativity, and of course, evolution. So even though colloquially you use theory to mean something that's not particularly well supported, theory has a really strong definition in science. So remember, if anyone says that evolution is just a theory, remember that so is gravity. So can you explain? What is a hypothesis? Can you make one yourself?